This assessment asks us to calculate KEQ of the acid-base reaction shown as a way of determining whether hydroxide is a strong enough base to deprotonate acetylene. We can use the pKa equation, where the pKa of the left side minus pK of the right side is going to be equal to pKeq. So let's start with a pKa here of acetylene. That pKa value is 25. The acid on the right side of the reaction is water. Water has a pKa of 16. So we can do 25 minus 16 is going to equal 9, which is equal to the pKeq. Now recall that the pKeq is going to mean that 9 is equal to the negative log of KEQ. We can divide both sides by -1 so that -9 equals the log of KEQ. Do the math, take 10 to both sides, and we get that KEQ for this acid-base reaction is 10 to the -9th. Now let's think about what that means. Because the KEQ is less than 1, the left side of the reaction is favored by quite a bit, which means that hydroxide shouldn't be a strong enough base to deprotonate it. In terms of our kind of qualitative understanding of pKa's, let's see if it matches. Well, if we have a pK of 25 on the left side versus a pK of 16 on the right side, that suggests that water is the stronger acid. We know that acid-base reactions move away from the stronger acid, so we would expect the left side of this reaction to be favored. A KEQ of 10 to the -9th makes sense.